Hello everyone. Hope all of you are safe and healthy. This is Divya here, Department of Chemistry, ASC Independent PU College. Today we will continue with the chapter of general principle and process of extraction of metals. We are at the last stage of the chapter. As I've told in the previous video that we are going to study about these elements, extraction of these elements in detail. That is, we are going to study about four important metal extraction here. That is zinc, aluminium, copper and iron. Now let me quickly recall the steps which are involved in this process of metallurgy. And let us apply these methods in extraction of metals. The first step is crushing and grinding of the ore. That is, you're going to crush and grind the ore once it is taken away from earth, because it will be in huge lumps. You need to crush and grind it. Next step is concentration or dressing of ore or benefaction of ore. In this step, once the ore is extracted, removed from the earth or obtained from the earth, it contains many earthy impurities. So we are going to remove this earthy impurity by different method, that is by leaching, froth flotation, hydraulic washing, and as well as magnetic separation methods, which you have already studied in the first video. So this process is called as concentration. The next process is isolation of metal from its concentrated ore. This is a very important step. It actually contains two steps in it. The first step, the concentrated ore is being converted into its oxide form, and then reduction of this metal oxide to metal. I think this you have already studied in the previous video, how to reduce metal oxide and how to convert this concentrated ore into metal oxides, that is by roasting and calcination. And then once the metal is in oxide form, the next step is reduction of this metal oxide to metal. This is done by suitable reducing agent or by electrolytic method or just by thermal reduction. The last step is purification or refining of metal in order to get 100% pure metal. So these are the steps involved in process of extraction. Now let us quickly apply these four steps in extraction of metals. Students, I request you all to check the previous videos again, if you have any doubts with these methods which already discussed earlier in the previous videos, and then you can proceed with this. The first metal which you're going to extract is zinc. Extraction of zinc. The ore of zinc, that is zinc, exists in earth crust as zinc blende, calamine, zincite. Now let us choose zinc sulfide here for this extraction of zinc. The ore which you're going to choose is zinc blende. First step involved in the process of extraction is crushing and grinding of the ore. So the ore which is obtained in the form of lumps is crushed and grinded. Next is concentration of ore. In this step, once the ore is obtained, naturally contains all earthy impurities that has to be removed by the method of concentration. And there are different methods in the process of concentration, and froth flotation is specially applicable for sulfide ores, for concentrating sulfide ores. So now this zinc blende, that is ZNS being sulfide ore, it has been concentrated by froth flotation. And the next step is, so what is froth flotation? Go to the previous video to get to know or to recall what is froth flotation. Next is, once the ore is being concentrated, it has to be converted into its respective oxide. I have again told, that is, if it is a sulfide ore, we are going to subject that to roasting, or if it is a carbonate ore, it has been subjected to calcination. the ore is already in the form of oxide, you can just skip this step. So what is your intention? After concentration of ore, it has to be converted into its oxide form, because metal is very easy to be extracted once it is in its oxide form. So the next step is conversion of ore into its oxide form. Since it is sulfide ore, we are going to subject that to roasting. What is roasting? The heating of this concentrated ore in a furnace in the presence of air or excess of air is called as roasting. Now the following reaction takes place over here, that is zinc sulfide. When it is treated with excess of air, it forms zinc oxide and liberating sulfur dioxide gas. The sulfur which is present here escapes as sulfur dioxide gas. And now we have our ore in the form of oxide. Do we want the zinc oxide? No. We want zinc. So remove this oxygen which is present along with zinc. How to remove this oxygen which is present along with the zinc? So reduction of this metal oxide to metal by process of what? Reduction. So this process of reduction is studied here. The reduction of metal oxide to metal. Here it is very simple. We know that zinc being a moderately reactive metal, we are going to apply the method which is used for reducing moderately reacting metal oxides are by using suitable reducing agent. This we have studied in the third video. Now, reduction of the zinc oxide is done by using coke. Coke acts as a better reducing agent to reduce zinc oxide to zinc. So it is heated to a temperature of 1673 Kelvin. It is one of the highest temperature. So zinc oxide treated with carbon or coke to a temperature of 1673 Kelvin, it forms zinc. So we have obtained what? Zinc. So in this step, reduction of metal oxide to metal, we have obtained zinc. This zinc naturally contains some small amount of impurity. This has to be refined in order to get 100% pure metal. In order to obtain this 100% pure metal, what is the next step? In the next step, we are going to subject this metal obtained for purification. So purification of zinc or refining of zinc is done by distillation. So distillation is especially applicable for the metals having low boiling point. So quickly go through what is distillation in the previous video, or quickly recall how is distillation done. So the metal is heated in a round bottom flask and it vaporizes. Since this metal is highly volatile in nature or have very low boiling point, it vaporizes quickly. These vapors are condensed and collected separately. The impurity will have higher boiling point compared to our metal. So in such cases, the metals which are highly volatile in nature is subjected to distillation. Now, in order to purify zinc, we are going to subject this to what? Distillation. So the metal is distilled off and collected by rapid chilling. This is how zinc is extracted to get pure metal of zinc from its ore of zinc sulfide. The next metal to be extracted is copper. So now let us study the extraction of copper. And remember, this is an examiner's favorite. That is, you can expect the question in 3 markers in your theory paper based on this extraction of copper. Now let us quickly check what are the ores of copper. The different ores of copper are copper pyrites, copper glands, malachite, cuprite. Now let us quickly subject this copper, ore of copper, to the process of extraction. So the first step is crushing and grinding of ore. So the ore which you've chosen is copper pyrites. What is copper pyrite? CuFeS2. And the second step is concentration of ore. Since it is sulfide ore, we are going to subject that to froth flotation process. So the concentration of ore is done by froth flotation process. Remember again, sulfide ores are subjected to froth flotation process. Now, what is froth flotation process? If you just don't remember, quickly go through the first video where we have gone through about or studied about the process of froth flotation. Okay, the next step of after concentration of the ore is roasting. What is roasting? Heating this concentrated ore in a furnace in presence of air is called as roasting. So now since it is sulfide ore again, we are going to subject this to roasting. Sulfide ores are always subjected to roasting. What are we doing in this step? We are trying to convert the ore into its oxide form. How to convert? By the process of roasting. So in this process of roasting, the concentrated ore is heated in presence of air. During this process, the following reaction takes place. The following reaction are like this, that is copper pyrites. When it is heated in presence of oxygen, first it forms cuprous sulfide and ferrous sulfide. Sulfur dioxide gas is liberated over here, and later these cuprous sulfide and ferrous sulfide on further heating with excess of oxygen is being converted into its respective oxide. So here you can see very clearly in the reaction, that is cuprous sulfide is being treated with oxygen or reacts with oxygen, forming cuprous oxide with the release of sulfur dioxide gas. And next, this roasted ore is being subjected to smelting. What is smelting? Heating this roasted ore to a high temperature with the presence of coke and sand is called as smelting. Since we are using high temperature, it is being carried out in blast furnace. I repeat again, what is smelting? Heating this roasted ore using coke and sand to a high temperature is called smelting over here. Now, remember again, we are adding coke and sand to this. This iron sulfide being highly reactive, it is being immediately converted into its oxide. That is, it forms ferrous oxide with the release of sulfur dioxide gas. This ferrous oxide now reacts with silica. Silica is nothing but SiO2, forming the iron silicate slag or slag of iron silicate is formed in the process. Now, this molten slag and the remaining cuprous sulfide collects at the base of the furnace into two layers. The upper layer is slag and the lower layer is called matte, which actually contains cuprous sulfide and trace of ferrous sulfide. Even after heating to high temperature, there is slag which is forming one layer and the other layer contains cuprous sulfide and ferrous sulfide. Still there is presence of these sulfides. We have not completely removed this sulfide. So this has to be subjected to bessemerization, that is next step. So after smelting, what do we obtain? We obtain copper matte. It is very clear, it is always asked in your examination for 1 mark. What is the composition of copper matte? Copper matte contains cuprous sulfide and ferrous sulfide. So this trace of cuprous sulfide and ferrous sulfide is still present, and in order to remove this, we are going to subject that to bessemerization. Remember again, our aim is to obtain only copper and not iron and the sulfide which is present along with it. So our intention is to only what? Extract the metal copper. So now let us quickly subject to this smelted ore into bessemerization. So in this process of bessemerization, we are going to use a pear-shaped tank. This is how the pear-shaped tank look like. I think you would have seen this kind of pear-shaped tank when there is a construction of house. That too, they apply concrete. They use one pear-shaped tank. That is how this pear-shaped tank look like. This pear-shaped tank is actually lined inside with magnesite, bricks of magnesite and quartz. Quartz is again nothing but silica. So you can also see this pear-shaped tank. This is how the pear-shaped tank look like. I repeat again, it is lined inside with bricks of magnesite and quartz. So now let us subject this to bessemerization. This pear-shaped tank is nothing but called as Bessemer converter. This pear-shaped tank is called as Bessemer converter. Now the copper matte from blast furnace is being transferred into this Bessemer converter, and some amount of silica is also added. So remember again, copper matte. What is copper matte? It is Cu2S, that is cuprous sulfide and ferrous sulfide. And now you can see that we have taken cuprous sulfide and ferrous sulfide, which is nothing but copper matte, and add some amount of silica to this. And now the blast of hot air is blown into this tank. This tank is being blown with a blast of hot air. When you blow the blast of hot air to the tank, you can see this ferrous sulfide is being converted into its respective oxide. Cuprous sulfide also gets converted into its respective oxide. The following reaction you can make out very clearly, that is ferrous sulfide which is present is being converted into iron oxide. This iron oxide or ferrous oxide combines with silica. Remember, you have added some amount of silica. It combines with silica or sand, forming iron silicate. This is a slag. Slag is nothing but impurity. Remember again, it forms a slag of iron silicate. Now, this copper sulfide which is present, the small amount of copper sulfide which is present is being oxidized or converted into its respective oxide, that is cuprous oxide, with the release of sulfur dioxide gas. So what was the gas released over here in this process? Sulfur dioxide. This cuprous oxide undergoes auto reduction with the remaining cuprous sulfide, and metallic copper is obtained over here. So the molten copper is now poured out of Bessemer converter. So you've got copper over here. This molten copper is poured out of this Bessemer converted, and it is being cooled. During the process of solidification or cooling, you can see that sulfur dioxide gas which is present comes out forming blisters. It comes out forming blisters, and hence it is called as blister copper. And this blister copper is 98% pure copper. And after obtaining blister copper, which is what 98% pure, it has been subject that to refining. The last step in this process of extraction of copper is refining. This blister copper, which is 98% pure, is being subjected to refining in order to obtain 100% pure copper. It is being purified by electrolytic method. What is electrolytic method of refining? Quickly check the third video where we have discussed about different process of refining which is done. Okay, so this is what the process of extraction of copper, and this is how the copper which is of 100% pure is being extracted from the ore of copper pyrites. If you're still thinking, what about this iron silicate slag? Remember, this iron silicate slag and the molten copper which is forms two different layers. This iron silicate slag, being lighter, forms upper layer and it is easily removed. And later, the lower layer, that is molten copper, is being subjected to solidification, or it is being poured out of the pear-shaped tank and it is cooled. So this is how the extraction of copper is done. Next is extraction of copper from low-grade ores. How to extract this copper metal from this low-grade ore? This is carried out by the process of hydrometallurgy. Then what is hydrometallurgy? It is the process of dissolving the ore in suitable reagent, and later this metal is extracted either by electrolysis or displacement with the metal by using a metal having electropositive value. So it has been, what is hydrometallurgy? It has been first dissolved with suitable reagent, and then this metal is extracted by electrolysis or by displacement using highly electropositive metal. Okay. Now let us see how this copper is extracted then. The copper ore is dissolved in a suitable reagent, and the process is called as leaching. Any ore dissolved in suitable reagent, the process is called as leaching. The solution containing cupric ions, that is Cu+2 ions, are treated with scrap iron or hydrogen. So in this reaction you can see very easily Once this copper ore is dissolved in suitable reagent, this cupric ions which are formed, that is Cu plus 2 ions which is formed, is been either treated with iron or hydrogen. That is, it forms copper. Why it has been treated with hydrogen? Since the reduction potential value of zinc is less than that of iron, the above reduction is faster in case of zinc. If you use zinc, this reaction is very fast. But zinc is not preferable because zinc is costlier than iron. So that is why it is being displaced by using highly electropositive metal of iron, which is highly economical. That is, in the low cost, we can highly displace this cupric ions forming copper. So this is why iron is used instead of zinc. In this video, we have studied about extraction of zinc and copper. In the next video, we will be studying about extraction of aluminium and iron. I request all of you all to check the video again for better understanding of the concept. Thank you. Stay home, stay safe, keep learning chemistry.